Okay, the last concept, well, not the last, but the next concept we need to learn is the common ion effect. And the common ion effect is exactly what it sounds like. We're going to have these substances that were insoluble, but we're looking at their equilibriums because they are slightly soluble. And that's what we're looking at in this unit. But they are dissolved in a solution that's not water, but it has a common ion in it. So, for example, this silver chromate is going to be dissolved in 0.100 silver nitrate. So can you guys figure out what the common ion is? It's the silver. See? Silver and silver. So, I have my equilibrium equation written here. And basically, I'm given the KSP in the problem. I also, in this problem, I'm going to tell you the molar solubility in water is 1.3 times 10 to the negative fourth. But what we're going to find is when there's a common ion present, the amount of this salt that can dissolve is less because the common ion is taking up some of the space that's in the solution. So what we need to do is we need to figure out what effect the common ion has on the molar solubility. So we're going to do, just like we did before, we have to have our equation for K. So I'm going to write it down here. KSP is equal to the products, which is Ag and CrO4 2 minus, and that's to the power, over the reactants. But again, remember, we have a solid, so we're not even really worried about the solid. Okay, we're going to find out how much of the solid can dissolve by finding out how much, we're going to solve for X of one of these, and X of chromate will equal the X from silver chromate. Because if the particles, however many particles there are that make chromate, has to be equal to the amount of particles there were that we started with. They can't just come from nowhere. So we have to do an ice table. So I'm going to draw it here because we don't need the solid. It's not in my K, so I don't need the solid. So because of the common ion, I start out with 1.00 molar silver nitrate. Silver nitrate. But remember, the nitrate's a spectator ion. So I start out with that much silver. And I start out with no chromate. And then, you know the change line, we're going to add 2x because some of this is going to dissolve. So we'll get 2x, and we're going to add x. So we're going to get 0.100 molar plus 2x, and we're going to get x. Now what we need to do is we need to substitute into our KSP equation. We're going to get 0.100 molar plus 2x squared times x. And that's equal to, it was given to me in the problem, 9 times 10 to the negative 12th. So, this looks like we're going to have to do some crazy algebra, but it turns out that we don't. We get to do something special in this problem, and that is called neglect the x. Because this number is so small, it's going to end up being less than 5% of the amount of the common ion dissolved. Okay, so 5% of 0.1, I think is going to be 0.05, or maybe even less than that. I'm trying to do it in my head. But we're going to neglect the x because we're going to assume that it's smaller. And then we'll just write neglect x because of 5% rule. Okay, we'll check it at the end to make sure we did it right. Make sure that it is 5% less. So with that x gone, our math just got so much easier. All we do is we divide by 0.100 squared. And we solve for x, and in this case we find that x is equal to, I'm cheating, 9 times 10 to the negative 10th. Okay, much smaller than 5% of the common ion. So Let's look now. We see that originally the molar solubility was 1.3 times 10 to the negative fourth. Now that there's this ion present, the amount of this silver chromate that can dissolve is much less. It's 9 times 10 to the negative 10th. So that's the common ion effect, and we're going to talk, we'll do some examples of it in class, and then we just have one last thing to build off of this on. So please make sure you know how to do the KSP problems and the molar solubility problems that there's videos for, and we're going to we'll review those and we'll do these, and then we'll move on to the last concept. Probably maybe next week, but we'll see. All right, have a good night.